There's one last observation I would like to make about acid-base chemistry. Let's start off, and I'll just use a strong acid, HCl, a strong acid. And so we know that a strong acid in water will react to make Cl minus plus H3O plus, and put in chat, is this reaction favorable or not? And the answer is it's favorable because the strong acid HCl is a stronger acid than the conjugate acid. But there's a very interesting corollary. If this reaction is favorable, that means that H2O, which is the base, H2O must be a stronger base than the conjugate base, and the conjugate base is Cl minus. In other words, because HCl is such a strong acid, its conjugate base is an incredibly weak base. And so the observation that we see then is the stronger the acid, the weaker the conjugate base. And the sister relationship, the stronger the base, the weaker the conjugate acid. And with that, let's do, first we make the observation. That means that the only bases weaker than water as a base, and water is a base, but it's not a very strong base. The only bases weaker than water are the conjugate bases of the strong acids. And the strong acids, remember, are, I'll just write them right here. The strong acids are HCl, HBr, HI, HClO4, HClO3, H2SO4, and HNO3. These are all the strong acids that we need to know in this course. And their conjugate bases, which are listed in this in the slide, are actually weaker bases than water. And let's do a couple of problems. We'll just do two problems. Is this reaction favorable? H3O plus NO3 minus going to H2O plus HNO3. And we're going to do this by looking at the base. Here's the base, and here's the conjugate base. And NO3 minus is the conjugate base of a strong acid. It's the conjugate acid of HNO3, and therefore this NO3 minus is a weaker base than water. The reaction is not favorable. Just one last acid-base chemistry problem, which is this one here. H2CO3 plus CO3 2 minus, and I'm going to rewrite it slightly, going to HCO3 minus plus HCO3 minus. And H2CO3 is the acid, CO3 2 minus is the base, and that means that one of these HCO3 minuses is the conjugate base, and the other HCO3 minus is the conjugate acid. And so think about, is this reaction favorable or not? Think about it and then write your answer. Favorable or not? And the answer is, we can do it two ways. We can look at the acid, and we can compare it to the conjugate acid. And we recognize neither of them is a strong acid, but we recognize that they belong to a cascade. And in a cascade, which member of the cascade is the strongest acid? And the answer is this one is the strongest acid. So, of the two acids, this one is the stronger acid. It's not a strong acid, but it's a stronger acid than the conjugate. And the reaction is therefore favorable. And you would get the same answer if you had looked at the bases, because CO3 2-, I keep on making that mistake. CO3 2- is the strongest of the three, is the strongest in the cascade of the bases. And therefore, this base is stronger than the conjugate base. That completes our discussion of acid-base chemistry, and in the rest of this lecture, we'll talk about the last two types of reactions in Chem 2070, precipitation to solution reactions, and we'll just do one or two examples of insertion and elimination.